Hello everybody, welcome into another lesson. So today we are going to talk about matrix multiplication. So in the last lesson we talked about matrix addition, subtraction, and scalar multiplication. This time we're talking about actually multiplying matrices themselves. So don't let this overwhelm you. I'm going to get into all of this, okay? So let's say we have some matrix A with its various entries. It's just some order m by n, so m rows, n columns. And then you have matrix B with its various entries. Its order is n by p, so it has n rows, p columns. In order to be able to multiply matrices, the number of columns in the first matrix, here in A, that's n rows, it must equal the number of, it's n columns. The number of columns in the first matrix must be equal to the number of rows in the second matrix. So you have n rows in the second, n columns in the first. In this case, we could multiply these two matrices since the number of columns in the first matrix, matrix A, equals the number of rows in the second matrix, matrix B. When you multiply matrices, it can sometimes change the order of what you're about to get. The order of multiplying the matrices, assuming you can do it, is going to be an m by p matrix. You'll end up having m rows and p columns for matrix A times B. Now, I want to point out that matrix multiplication, unlike normal multiplication, which is commutative, matrix multiplication is not commutative. So if you can take matrix A times B, and even if you can take matrix B times A, the results are not necessarily equal. They're not going to be equal. And even if you can take matrix A times B, you may not be able to take matrix B times A. And then for the next part, this is a 3 by 3 identity matrix. This is called the identity matrix. And you can have an identity matrix of any order. You'll know it's an identity matrix when you have ones going down the main diagonal and all other entries are 0. That's how you'll know it's an identity matrix. But if I take a matrix A times that I means the identity matrix, as long as you can multiply them, I should just get A back. That's the matrix equivalent of multiplying by 1. And then to square a matrix, that's the same as taking the matrix times the matrix. But the caveat with that is, and the real kicker is, you may not be able to do that. So you have to make sure you can even multiply A times A. So that's about being sure you can multiply matrices. Now, let's see if, let's set up an example of how you would actually do the matrix multiplication if you can do it. Well, first, let's introduce how that's going to work. So, let's say I have matrix A. I'm going to make this a 2 by 2 matrix. You'll have entries A, B, C, and D. Let's make matrix B. We'll make those entries E, F, G, and H. So we want to see if we can do matrix AB. Is it even possible? Well, first thing you need to do is determine the order of your matrices. Matrix A is a 2 by 2. Matrix B is also a 2 by 2. Well, the number of columns in the first matrix does equal the number of rows in the second matrix, so yes, it is possible. That means AB should also then end up being a 2 by 2 matrix, So you'll take the rows in your first matrix. It'll be the rows in your first matrix times the columns in your second matrix. So AB should also be a 2 by 2 matrix. And the good news is, if you have two matrices and they're both square matrices, then you should end up, the product of those should be a square matrix of the same dimensions. It only gets a little hairy when they're not the same dimensions. But A times B, so what's that going to look like? So we know we should have a 2 by 2 matrix. So what you have to do is, you're going to get four numbers. You take the first number in your first row of the first matrix, so that would be A, times the first number of your first column in the second matrix. So the first number would be AE, plus you'll take the second number in the first row of your first matrix, matrix A, which would be B, times the second number of your first column, which would be in a matrix B. So the first number should be AE plus BG. And then we're going to repeat the cycle to get the second number of the first row of AB. So then you'll take the first number of your first row of matrix A, multiply it by the first number of the second column in matrix B. So this would become AF, plus you'll take the second number of the first row of your first matrix times the second number of your second column of the other matrix. So that would be AF plus BH. And then you got all your first row of AB. Now we need to get your second row. So that's going to be, in matrix A, you'll take the first number of the second row times the first number of the first column of B. So you would end up having CE plus, you'll take the second number of your the second number of your second row in matrix A times the second number of your first column in matrix B, so that'd be plus DG. And then you need to get one more number, so take the first number of your second row in matrix A times the first number of your second column in matrix B, so that would be CF, plus you'll take the second number of your second row of matrix A times the second number of your second column matrix B, so plus DH. So the result, if this is a 2 by 2, it's obviously going to vary depending upon the dimensions you get. You would have AE plus BG, AF plus BH, and then you would have CE plus DG. Then you would have CF plus DH. Now we'll get into some actual examples here. Let's do some actual examples. Alright, so we have a matrix A, which is going to be entries 2, 1, negative 3, 4, negative 1, 6. Matrix B is going to end up being 0, negative 3, 0, 4, 0, 2, 8, negative 2, 7. Alright, so you got matrix A with entries 2, 1, negative 3, 4, negative 1, 6. Matrix B has entries 0, negative 3, 0, 4, 0, 2, 8, negative 2, 7. So we're going to see if we can do matrix AB. First thing you need to do is determine, can you even do it? And in order to do that, you need to establish the order of each matrix. So the order of matrix A is going to be 3 rows but 2 columns. So this is a 3 by 2 matrix. Matrix B is going to be a 3 by 3 matrix. Immediately we see that in AB you have 2 columns in the first matrix and 3 rows in the second matrix, which don't equal each other. So we can say that AB is not possible. We cannot multiply these 2 matrices because the number of columns in A does not equal the number of rows in B. So AB is not even possible. What if we were to try to do BA? Let's switch it around. Can we take BA? Well, BA, that's going to end up being, you would have a 3 by 3 times a 3 by 2. The number of columns in B equals the number of rows in A, so actually it is possible. So in this case you can do it. Let's go ahead and write these matrices out over here to illustrate what we're about to do. Make sure I'm looking at the right matrix. I don't want to miss the I don't want to mess up the entries. Alright, so this is a 3 by 3 matrix, right? This is a 3 by 2 matrix. So the number of columns in the first matrix equals the number of rows in the second matrix. That means our result should be a 3 by 2 matrix. So doing the multiplication is going to change the order. So let's see what that's actually going to give us here. We should get a 3 by 2 matrix. So what we need to do now, stick with your first row, take the first number of your first row, which is 0, times the first number of your first column of the second matrix, which is 2, plus take the second number of your first row. You know what, maybe I better come down because I could see where I'm going to run out of room. So forgive me for that. Goodness, if I could quit bumping stuff, it might be a good day, right? I'm so clumsy. We're going to get it. Alright, there we go. Okay, let me bring this down here, okay? So, anyway, as I was saying, take the first number of the first row of the first matrix times the first number of the first column of the second matrix. So you'll have 0 times 2 plus, you'll have the second number of the first row of the first matrix, which is -3 times the second number of the first column of the second matrix, which would be also -3. And then you'll take plus the third number of the first row of the first matrix, which would be 0, times the third number of the first column of the second matrix, which would be -1. That's just it for your first number. Now we got to repeat this to get our second number. This time we're going to multiply the first row by the second column. So you'll take the first number of the first row, which would be 0, times the first number of the second column, which would be 1, plus you'll take that -3 times that 4, plus you'll take that 0 times that 6. Alright, so there's now this is starting to come together. You have both numbers for your first row. Now we need to start into our second row. So the first number of the second row, you'll take that 4 times 2, and then you'll take that 0 times negative 3, plus you'll take that 2 times that negative 1. Now we need to get the second number of the second row, so this is going to be that 4 times that 1, plus you'll take that 0 times that 4, plus you'll take that 2 times that 6. Then now we need to get our final row. So take that 8 times that 2, plus take that negative 2 times that negative 3, plus take that 7 times that negative 1. Alright, now we need to get the final number of the third row, so take the 8 times the 1, plus take the negative 2 times 4, plus take the 7 times 6. Alright, let's simplify this, of course. So you'll end up with 0 times 2 is 0, plus negative 3 times negative 3, that's plus 9, plus 0 times negative 1 is 0. There's your first number of the first row. Then 0 times 1 is 0, plus negative 3 times 4, that's minus 12. And then plus 0 times 6, that's just a plus 0. Alright, 4 times 2 is 8, plus 0 times negative 3, which is 0, plus 2 times negative 1, so that'd be a minus 2. Alright, next number, 4 times 1 is 4, plus 0 times 4 is 0, and then plus 2 times 6, that's plus 12. Now let's get to the third row. 8 times 2 is 16, plus negative 2 times negative 3, that's plus 6, plus 7 times negative 1, so that's minus 7. Then let's get the final number of the third row. 8 times 1 is 8, plus negative 2 times 4, that would actually end up being minus 8, and then plus 7 times 6 is 42. So now let's add all these together. You'll get your final result for B times A. You'll end up with the first number of the first row is 9, second number of the first row is negative 12, first number of the second row is going to be 6, second number of the second row would be 16, and then third number of the first row would end up being 15, second number of the third row would end up being 42. So indeed, as you can see, you end up with a 3 by 2 matrix with entries 9, negative 12, 6, 16, 15, and 42. So I'll pause a second, let you collect any notes you need to or anything like that, and then we'll move on. We're going to see if we can do A times A. Alright, so pause the video if you need to collect all this. Well, last but not least, let's see if we can evaluate A squared, which A squared is the same as A times A. Well, A is a 3 by 2, right? We're going to take a 3 by 2 times a 3 by 2, right? There's just one problem. The number of rows in the the number of columns in the first A is not equal to the number of rows in the second A. So in this case, it's not possible to do A squared. That actually is not going to be possible, because the number of columns in the first A does not equal the number of rows in the second A. So paying attention to the order of matrices is incredibly important. All right. Let's see here. So matrix A has entries -1, 6, -4, 5, 0, and 3. Matrix B has entries 2, 3, 0, and 9. So matrix A has entries -1, 6, -4, 5, 0, 3, 2, 3, 0, and 9. Is it going to be possible to do this? Is it going to be possible to do A times B? We'll start with A times B. In order to do that, we need to determine the order of the matrices, right? So matrix A has 3 rows but 2 columns. So you have a 3-row by 2 column. Matrix B is 2 rows by 2 columns. So yes, it is actually going to be possible to do A times B, because the number of columns in A equals the number of rows in B, which means your result for A times B should be a 3 by 2 matrix. It will be possible. So let's go ahead and write these matrices out over here so we can see what we're referring to when we do this. So here's matrix A that I'm currently writing out. I'm going to write matrix B right next to it. Alright, so we've determined we can multiply matrices A times B. We've determined the result should be a 3 by 2 matrix. So let's go ahead and work on getting these entries, shall we? So that means I need to take that -1 times 2 plus that 6 times that 0. Alright, so I've done all I can for the first number of the first row. Now I'm going to take the same numbers of the first row, multiplying by the second column of the second matrix. So I should end up with -1 times 3 plus 6 times 9. Alright, so I've done all I can for the first row entirely. Now to get the first number of the second row, I'm going to take the second row times the first column. So that would be -4 times 5. No, wait, what am I looking at? -4 times 2 plus 5 times 0. Now to get the second number of the second row, take the second row times the second column, so that would be -4 times 3 plus 5 times 9. Now let's get the third row of this matrix. So we're going to take the third row times the first column, so that's going to end up being 0 times 2 plus 3 times 0. And then get the second number of the third row. You'll take the third row times the second column. So 0 times 3 plus 3 times 9. And of course now we can definitely simplify this. Let's do all the multiplication. You'll end up with -1 times 2, -2 plus 6 times 0 is 0. Then negative 1 times 3, that's negative 3 plus 6 times 9 is 54. Alright, negative 4 times 2 is negative 8, plus 5 times 0 is 0. Negative 4 times 3 is negative 12, plus 5 times 9 is 45. 0 times 2 is 0, plus 3 times 0 is also 0. 0 times 3 is 0, plus 3 times 9 is 27. So for the final result of A times B, we should end up getting negative 2, 51, negative 8, 33, 0, and 27. So matrix A times B, in fact, turned out to be a 3 by 2 matrix with entries negative 2, 51, negative 8, 33, 0, and 27. And pause the video if you need to see how we got there. We're going to move on to determine if we can do matrix B times A. I'm going to rewrite the order real quick. So 3 by 2, let's keep the order up. 2 by 2. Let's, of course, now, can we do matrix B times A? That's the big question. Well, matrix B times A, okay, so matrix B is a 2 by 2 matrix, right? We're going to take a 2 by 2 matrix times a 3 by 2 matrix. Well, the problem is the number of columns in B does not equal the number of rows in A, so matrix B times A is not possible. That will not even be possible. Now, last question, what about A squared? Well, we know that's equal to A times A, right? A times A, that would have us taking a 3 by 2 matrix times a 3 by 2 matrix. Well, the number of columns in the first A is not equal to the number of rows in the second A, so matrix A squared is also not possible in this case. So this is one proof here, an example that matrix multiplication is not commutative. Alright. Why don't we do a square? Why don't we do 2 square matrices of the same dimensions? So yes, this is going to be a rather long one because I can tell you right now these are all going to be possible, but I want to show you still, even if you can multiply them every way, that matrix multiplication is not commutative. So let's take matrix A to have entries 5, 0, 0. Matrix B, and then we'll have 0, negative 8, 0. And then we'll have 0, 0, 7 for matrix A. Matrix B is going to have entries 1/5, 0, 0. Now, you know what? That's not an example I actually want to do. There's a reason for that. That would actually tie into the next lesson on inverse matrices, but let's do, it's still going to be 3 by 3 matrices, but let's do 0, 0, 5. 0, 0, negative 3, 0, 0, 4. Matrix B will have entries 6, -11, and 4. 8, 16, and 4. And then 0, 0, 0. Alright. So, first thing we want to do is see if we can do A times B, right? Can we take matrix A times B? Well, let's determine the order of each matrix. Matrix A is a 3 by 3 matrix, meaning it's a square matrix. Matrix B is also a 3 by 3 matrix, also a square matrix. Actually, both these matrices have the exact same dimensions, so the number of columns in A definitely equals the number of rows in B. We can clearly take A times B, and that means we're also going to get a 3 by 3 matrix for our result. So matrix A times B should be 3 by 3. Alright, so let's get the first number of the first row. So let's take the whole first row of A times the first column of B. So that's going to end up being 0 times 6 plus 0 times 8 plus 5 times 0. Alright, there's the first number of the first row. Now to get the second number of the first row, take your whole first row times your second column. You know what? I need to make room here. Forgive me. I just saw what I did. I'm going to end up running out of room by the time I get to the third number. Alright, so 0 times 6 plus 0 times 8 plus 5 times 0. Alright, now we take the first row times the second column, so this would end up being 0 times -11 plus 0 times 16 plus 5 times 0. And then we need to get the third number of the first row, so take your first row times your third column. So that would end up being plus, not plus, we're doing the whole third number itself, so that'd be 0 times 4 plus 0 times 4 plus 5 times 0. And that's just all three numbers of your first row. It's going to be a little grueling. Now let's see if we can take, let's do the second row times the first column. So that's going to end up giving you 0 times 6 plus 0 times 8 plus -3 times 0. Now let's do the second number. So we should end up getting, let's see, a second number of the second row, so 0 times -11, and then we'll end up taking 0 times 16 plus 0 times 16 plus -3 times 0. Now let's do the final number of the second row. So we'll take the second row times the third column. So we'll have 0 times 4 plus yet another 0 times 4 plus -3 times 0. Alright, let's do the third row. So third row times the first column, that's going to be 0 times 6 plus 0 times 8. Then you'll have 4 times 0 plus 4 times 0. Second number of the third row, so the third row times the second column, that'd be 0 times negative 11 plus 0 times 16 plus 4 times 0. And let's do the final number. So the third row times the third column, so you'll have 0 times 4 plus 0 times 4 plus 4 times 0, which when we simplify would give us 0 plus 0 plus 0, and 0 plus 0 plus 0. And then we'll also have a 0 plus 0 plus 0. 0 plus 0 plus 0. 0 plus 0 plus 0. And then we'll end up having 0 plus 0 plus 0. 0 plus 0 plus 0, 0 plus 0 plus 0, and then 0 plus 0 plus 0, which would simplify into your zero matrix. You get what's called a 3x3 zero matrix. You literally get that all entries are 0. So you should get a 3x3 zero matrix for matrix AB. And now a big question is, can we do matrix B times A? So matrix AB is just the zero matrix. Now, can we do matrix BA? We can, because they're both 3x3 matrices, meaning our matrix BA should be a 3x3 matrix. So let me go ahead and write these matrices next to each other. So 6, negative 11, and then 4, and then let's see, 8, 16, 4, 0, 0, 0 times, let's see, 0, 0, 5, 0, 0, negative 3, 0, 0, 4. So we're going to get another 3x3 matrix. Let's go ahead and do B times A. So to find the first number, we're going to take the whole first row of the first matrix times the first column of the second matrix. So that's going to end up giving us 6 times 0 plus negative 11 times 0 plus 4 times 0. Now to get the second number, take your whole first row times your second column. So that'll end up being 6 times 0 plus negative 11 times 0, and then take 4 times 0, and then we still have the business of the third number. So take your whole first row times your third column. So you'll have 6 times 5 plus negative 11 times negative 3 plus 4 times 4 Now we've got our entire first row. Let's do the entire second row. So to get your first number, take your entire second row times your first column. So you'd end up having 8 times 0 plus 16 times 0 plus 4 times 0. And then let's see here. Get our second number, take your second row times your second column. So once again, it's going to end up being 8 times 0 plus 16 times 0 plus 4 times 0. And then we need to get the third number of the second row. So take your second row by your third column. So that's going to be 8 times 5 plus 16 times negative 3 plus 4 times 4. There's your entire second row. Let's do your third row. So to get the first number of the third row, take your entire third row times your first column. That's going to be all zeros. Let's just cut to the chase. You'll have all zeros there. If we want to get the second number, you'll take your entire third row times your second column. Again, that's nothing but zeros. That should be easy. As a matter of fact, your third number, we take the third row times the third column. That's nothing but zeros. So that's going to make life a lot easier. Let's go ahead and simplify this. So your first number of the first row is nothing but zeros. Second number of the first row, also nothing but zeros. Now, the third number of the first row, 6 times 5 is 30. And then negative 11 times negative 3, so that's plus 33. And then plus 4 times 4 is 16. And then the first number of your second row, all zeros. The second number of your second row is all zeros. But then the third number of your second row, so 8 times 5 is 40. And then 16 times negative 3, that's actually minus 48. And then 4 times 4, that's actually plus 16. And then your entire third row was nothing but zeros. So this would simplify into the 3 by 3 matrix 0, 0. 30 plus 33 is 63 plus 16, that's 79. 0, 0. Alright, 40 minus 48 is negative 8 plus 16, that's positive 8. Then your entire third row is zeros. So notice you got a different 3 by 3 matrix for BA than you did AB. When we did AB, we just got a 3 by 3 zero matrix all across the board. We did BA, we got 0, 0, 79, 0, 0, 8, 0, 0, 0. That just proves that matrix multiplication is not commutative. Now, let's do A squared. Good news is we know we can definitely do A squared because A is a square matrix of 3 by 3. That means the rows and columns will match in both your A's, so we'll be able to do it. But let's see what we get here. Let's take A squared, which means that's A times A, which means you should also get a 3 by 3 matrix for this. So let's write out matrices both matrices A right beside each other. 0, 0, 5, 0, 0, negative 3, 0, 0, 4. And then let's write another matrix A right beside it. So 0, 0, 5, 0, 0, negative 3, 0, 0, 4. So let's see what we get here. Alright, so to get the first number of the first row, multiply your entire first row times your first column. That's definitely going to be all zeros, right? What about for the second number? You'll take your entire first row times your second column. Well, that's just also going to be all zeros, right? Now to get your third number, you're going to take your entire first row times your third column. Well, that's not all zeros. Granted, you'll have a 0 times a 5, plus a 0 times a negative 3, plus you'll have that 5 times that 4. So that just changed things. Alright, now let's get your entries for your second row. So the first number is going to be the entire the entire second row times the first column. Well, that's going to be all zeros. Second number is the entire second row times the second column, also all zeros. But the third number, the second row times the third column, so you'll have 0 times 5 plus 0 times negative 3 plus negative 3 times 4. And then let's get the third row. So take your entire third row times your first column for your first number. You'll get a 0. To get the second number, take your third row times your second column. You'll also get 0. But to get the third number, so we'll take 0 times 5 plus 0 times negative 3 plus 4 times 4. Let's simplify a little bit. You'll end up with 0, 0, and then you'll have 0 plus 0 plus 20. Alright, then you'll have 0, 0, and then see, you'll have 0 plus 0 minus 12, and then you'll have 0, 0, alright, 0 plus 0 plus 16, giving you the final result for a squared should end up being 0, 0, 20, 0, 0, negative 12, 0, 0, 16. So matrix A squared is going to be 0, 0, 20, 0, 0, negative 12, 0, 0, 16. Alright. I would like to do one more. I don't think it's going to be nearly as bad though. Much smaller matrices we're working with. And probably some of them we won't even be able to multiply. So that's about as bad as we get. Also, there are graphing calculator tools for multiplying matrices. So when you go on to take a course like linear algebra, you'll probably largely be relying on graphing calculators. But last problem, matrix A, a very small matrix with just entries 5, 6. Matrix B, let's see, negative 3, negative 1, negative 5, negative 9. Alright, Well, let's determine the order of these matrices first. Matrix A has 2 rows and 1 column, so matrix A is a 2 by 1 matrix. Matrix B has 1 row but 4 columns, so this would be a 1 by 4 matrix. First, let's see, can we end up doing matrix A times B? Well, matrix A times B, okay, that means we're going to take a 2 by 1 matrix times a 1 by 4. Well, the number of columns in A matches the number of rows in B, so yes, we can totally do that. This will work. That means our result should actually end up being a 2 by 4 matrix. So we've determined that matrix AB is going to be a 2 by 4 matrix. So let's write these matrices side by side, and we will do the multiplication. 5, 6 times -3, -1, -5, and -9. Alright, so to get the first number of the first row, we need to take the entire first row times the first column. So that would just be 5 times -3. Get the second number of the first row. We take the first row times the second column. That would be 5 times -1. Get the third number of the second row of the first row. We'll take the first row times the third column. So that would be 5 times -5. To get the fourth number of the first row, take the first row times the fourth column. That would end up being 5 times -9. There's your entire first row. Now we need to get the second row. So to get the first number, take your second row times your first column. That's going to be 6 times -3. Then to get the second number, take that 6 times that -1. To get the third number, take 6 times -5. To get the fourth number, take 6 times -9. This will simplify actually very nicely into -15, -5, -25, and then -45 in the first row. And then in the second row, you'll have -18, -6, -30, and -54. So matrix AB is in fact a 2 by 4 matrix with entries -15, -5, -25, -45, -18, -6, -30, -54. So that's matrix AB. Now, of course, we need to determine, can we do BA, and then can we do A squared? Alright, so let's determine, can we do matrix BA? Is it possible? Well, matrix B is a 1 by 4 matrix. Matrix A is a 2 by 1 matrix. Well, the number of columns in B does not equal the number of rows in A, so matrix B times A is not even possible. Now the last question, can we do A squared? Which we know to be A times A. Well, matrix A is a 2 by 1 matrix on both counts, but in the first matrix A, the number of columns does not equal the number of rows in the second matrix A, so actually A squared also is not going to be possible. So only AB was possible, but BA and A squared were not possible. Alright, so that's it for this lesson. Next lesson, we're going to take the inverse of a 2 by 2 matrix. We're going to start talking about inverse matrices and what those are. So I hope everyone has a great day. Take care.